Hello and welcome to lesson 1H. I can find the probability that a given point in a diagram is within a certain region. So we're basically studying today a concept called geometric probability. And what geometric probability basically is determining, given some total outcomes, what's the likelihood that I have a successful outcome? So we always look at successful outcomes over total outcomes, and we apply that even in geometric situations. For example, point X is going to fall somewhere in region A, and region B is completely within region A, and I want to determine the probability that the probability that a point falls in region B. All we do is we do the area that we're interested in, that region B, and we divide it by all of the possible area, the total area of region A. So let's take a look at this one down here. So find the probability that a randomly selected point in the rectangle is also in the shaded region of the figure below. So we are looking for the probability that we land in this shaded region. Well, that's going to equal the area of interest. Well, the area of my shaded region is actually the area of that circle. And I'm going to divide that by the area of the largest thing in the picture, in this case, the rectangle. Well, when we work that out, my area of a circle is pi times r squared. Well, looking at this would be r. That's half of this side here, so my radius here would be 5. So I do pi times 5 squared, and that I divide that by the area of the rectangle, which would be 10 times 300. Or, as we go along, that's 25 pi. Not what I do 10 times 300, I meant 10 times 30, friends. I'm sorry, I was working out in my head, which I shouldn't have done. Oh, 25 pi over 300, which reduces to pi over 12, or I can plug that in my calculator. I can do pi divided by 12 and get 0.261799. So, 0.261799. These guys are my answers. Where the pi over 12, that's the exact answer, and the decimal is my approximate answer, because of course that decimal would keep going on forever, so we've actually rounded for that answer. Now, probably the case where you see geometric probability the most often in the real world is darts. Figuring out what your probability of hitting the bullseye on a dartboard is the best example of geometric probability, because you're really looking at, given all of the places I could hit with this dart, and we're assuming that you're good enough to hit the dartboard, if I otherwise have no skill, what's the likelihood that I hit the bullseye? And so let's take a look at that. So the width of each ring in my dartboard here is 4 inches. That means this guy here is 4 inches, this guy here is 4 inches, and the bullseye has a diameter of 4 inches. So from here to here is also 4 inches. I want to find the probability that the dart hits the bullseye. So the probability of hitting a bullseye is the area I'm interested in. That's the area of my bullseye divided by the area of the whole picture, the area of the total. Well, let's break that down a little bit more. We really have 3 concentric circles here, where this circle has a radius of 2. This circle has a radius of 2 plus 4, which is 6. That's my medium circle. And this circle has a radius of 2 plus 4 plus 4, which is 10. I'm going to refer to our circles as small, medium, and large. So the radius of my small circle is 2. The radius of my medium circle is 6, and the radius of the large circle is 10. So that's going to be important as we work through this. Well, if I'm looking at the probability of the bullseye, the area of the bullseye is really the area of my small circle. And the area of the total is really the area of the largest circle in the picture. Okay, so that's what we're going to do. So my probability will equal area of the bullseye, that's pi r squared, so pi times 2 squared, divided by area of the total. Well, my large circle has a radius of 10, so pi times 10 squared, or I get 4 pi over 100 pi. That reduces, the pi's cancel, and the 4 and 100 become 1 over 25, which if we plug that in our calculator is 0.04. So that's the probability of hitting the bullseye. You have a 4% chance of hitting the bullseye in this particular picture. And our bullseye is actually pretty big in this picture, so you can imagine how little of a chance you actually have on a real dartboard. So let's take a look at the next one. What's the probability that I hit the middle ring? That's excluding the bullseye. Well, the probability of hitting the middle ring is really equal to the area of the ring itself divided by the area of the total. Well, how do we get the area of a ring? Area of a ring is always a subtraction problem. I don't have a formula for a ring. However, I do have formulas for circles. And this is kind of like punching the hole out of a donut. If I start with the area of the full medium circle, and I then subtract the area of a small circle, I'm left with just the ring, okay? So that's really what I'm interested in. And then I'm going to divide that by the area of the total. We already agreed that the area of the total is really the area of your largest circle in the picture. So let's plug in. So my probability is going to equal area of my middle circle, that's pi times 6 squared, minus area of my small circle, pi times 2 squared, divided by area of the largest thing in the picture, which is pi times 10 squared, which gets me 36 pi minus 4 pi divided by 100 pi, or 32 pi over 100 pi, which is going to reduce to 8 over 25. If I plug 8 over 25 into my calculator, 8 divided by 25, and remember you have to hit control then equals to get your oh no, I didn't do it, did I? Here, you hold control equal to get the decimal, okay? Some of your calculators are a little bit funky in that. Ooh, nope, not there. I'm looking for it, guys. Here it is. Okay, so that we actually have 32%, or 0.32 is my probability. So you have a 32% chance of hitting the bullseye, or hitting the middle ring in this picture. Now, what about hitting the outer ring or the bullseye? Well, this is really an addition problem. This is really considered the probability of hitting the outer ring plus the probability of hitting the bullseye. Okay, well, let's just talk about the outer ring at first. The probability of my outer ring is really the area of that outer ring divided by the area of the total. And then the area of the bullseye is the probability of the bullseye is area of the bullseye divided by the area of the total. Now, just like before when we were talking about the middle ring, we don't have a formula for a ring. However, we can do subtraction. If I take this whole circle and then subtract out the middle circle, I'm left with just the outer circle, okay? So that's what we're gonna do. We're gonna do the area of the largest circle, and then we're gonna remove the area of the the medium circle to be left with just the area of the ring, okay? And then we divide that by then the area of the large circle because that's our total. Added to that, the area of the bullseye is really just the area of my smallest circle, right? Area of the small circle, and we divide that by the area, what am I doing? Area of the largest circle. So let's plug that in. My large circle, the formula for area would be pi times r squared, where r is 10. So I do pi times 10 squared minus area of my medium circle would be pi times medium's radius is 6 squared divided by the area of the large, which is pi times 10 squared, plus area of the bullseye or area of the small circle will be pi times 2 squared divided by the largest thing in the picture, pi times 10 squared. And we're going to simplify these guys now. So I get probability equals 100 pi minus 36 pi divided by 100 pi plus 4 pi over 100 pi, or 64 pi over 100 pi plus 4 pi over 100 pi. These combine to be 68 pi out of 100 pi. We're now going to reduce that. The pi's cancel. 68 over 100 becomes 17 over 25, which when I plug it into the calculator gets me a probability of 0.68. So that is the probability. We have a 68% chance of hitting either the outer ring or the bullseye. All right, guys, that's the end of this lesson. Please take a look at the MML practice, but also, guys, your practice is on paper for this lesson, because this one, there's some chances for you to get partial credit on this. We want you to practice it on paper as well. So thank you all very much.